friends, welcome back to your UPSC. So today we'll start with another topic of climatology, that is cyclones and anticyclones. So let's get started. So in cyclones and anticyclones, first we will complete cyclones and then we will move over to anticyclones. Now, cyclones. What exactly are cyclones? Cyclones are centralized low pressure surrounded by closed isobar having increasing pressure outwards. Okay, so we have centralized low pressure area and then we have closed isobars. Okay, these are closed isobars which are having increasingly high pressure. Okay, as we move outward, the high pressure will increase. Okay, like for example, if this area is having 900 millibar of atmospheric pressure, okay, and this area will be having 101 millibar of pressure, okay, atmospheric pressure. Then the pressure of another ring will be 100,002. Then it will keep on increasing like this. Okay, so we have centralized low pressure and increasingly high pressure as we move outward. So this is the condition of cyclones. Okay, now what are the basic characteristics of cyclone? So first basic characteristic that we have done, we have centralized low pressure surrounded by increasing high pressure belts. Okay, next is we have closed air circulation from outside to inside. Now this is closed air circulation, means the air is coming from all sides. Okay, so the air is coming from all sides. Okay, next is in the northern hemisphere the cyclones move anti-clockwise, while in the southern hemisphere it moves clockwise. Now we all may get confused that whether in northern hemisphere cyclone move anti-clockwise or clockwise. So there is a very nice trick. It is make north like this. Okay, now put arrow. Now you will see that the movement of this arrow will be anti-clockwise. Okay, so in northern hemisphere it will move anti-clockwise, while in southern hemisphere it will move like this. So on both the ends, if we put arrow and then move this on its direction, okay, then in southern hemisphere the cyclones will move clockwise. Okay, so this is a simple trick which will make it easy to remember that what is the direction of movement of cyclones in northern and southern hemisphere. Now their shape range from circular to elliptical to V-shaped. Okay, on the basis of their location they are classified into two types. So the first type is extratropical or temperate cyclone, and the second one is tropical cyclone. So as the name suggests, the temperate cyclones will be found in temperate region and tropical cyclones would be found in tropical region. Okay, so first we will complete temperate cyclones. So the temperate cyclones, they are low pressure centers produced in mid latitudes. So mid latitudes ranges from 35 degree to 65 degree north and south latitude. Okay, and they are characterized by converging and rising air. So air converges and rises up. Okay, so air will converge and then rise up. Okay, we have cloudiness here and precipitation. So we have converging and rising air, then we have cloudiness and precipitation. And these type of cyclones, they are formed by frontogenesis process. Frontogenesis we have studied in last class. So frontogenesis process forms temperate cyclones. Okay. Now we will look into type of temperate cyclones. So on the basis of thermal and pressure variation, the temperate cyclones are basically divided into three types. So what are these three types? These three types are, first is dynamic cyclone, second is thermal cyclone, and the last one is secondary cyclone. So this dynamic cyclone, it is the real temperate cyclone. Why? Because this cyclone is the one which is formed by convergence of two contrasting air masses, or two air masses moving in opposite direction and having contrasting characteristics. Okay, and these cyclones, they affect large area. They affect large area in mid latitudes. Okay, next we have thermal cyclone. Thermal cyclones, these are another type of temperate cyclones, and these cyclones are formed due to formation of low pressure center. Okay, so low pressure center is formed on the continent in summer in the temperate region, and as the low pressure is formed, the winds from all direction, they converge in this low pressure area. Okay, so this is how thermal cyclones are formed, and these thermal cyclones, they are stationary at their place. Okay, and here fronts are not developed. Fronts are just developed in dynamic cyclones. Why? Because here we will have contrasting air masses that will be working, but in thermal cyclones we will there will be generation of a low pressure area, because of which cyclones will occur. Okay, lastly we have secondary cyclones. So these secondary cyclones are developed due to the passage of cold wind over the warm sea after occlusion of main cyclone. So after the main cyclone is occluded, the cold sea moves over warm sea. Okay, and this forms secondary cyclone, and these types of cyclones are short lived and are very weak. Okay, so these were the three types of cyclone. Now we will look into weather associated with temperate cyclones. So first is during arrival of cyclone. So during arrival of cyclone, consider that the direction of wind is from western side. So we have western direction. Now as the cyclone will come nearer to the observer, the wind velocity will slow down considerably, and the air pressure will also decrease. So wind velocity will slow down, air pressure decreases, and we can see a halo around sun and moon. Okay, so around sun and moon we can see halo formation, and the clouds like cirrus and cirrostratus clouds can be observed in the western direction of the observer. And as the cyclone approaches near, okay, when it is very close, the temperature suddenly increases, and the wind direction, it changes from easterly to southeasterly. Okay, so the wind direction, it changes changes from easterly to southeasterly. Okay, and then we will have thick cover of cloud, and the sky become dark, thick and low clouds. Sky is covered with dark, thick and low clouds. Okay, this is during the arrival of cyclones. Now if we have warm fronts, so then we will have warm frontal precipitation. Now as we have studied that during the warm fronts, what will happen? The warm air will rise by its own. Okay, and clouds will become, so clouds will be formed. So here the clouds will become very thick and dark with the arrival of warm front, and there will be heavy shower because of nimbostratus nimbostratus clouds. So in warm fronts we don't usually have thunder or lightning sort of things. Okay, now why it happens? Because the warm air, it rises slowly upward, and as it rises upward, the the air, it saturates and it condenses and it forms cloud. Okay, now warm fronts, they remain for quite a long period of time, and the sky is overcasted by dark clouds, because of which sun is not visible for several hours. Okay, so that was in warm front. So here sun will not be visible for several hours because the cloud will be overcasted by, sorry, the sky will be overcasted by dark clouds. Okay, next we will have warm sector. So in warm fronts, there a passage will become, sorry, after warm frontal precipitation, what will happen? After frontal precipitation is done, okay, then we will observe a sudden change in pre-existing weather. Okay, the wind direction that was east to southeasterly, now it will change to southerly. The sky will become cloudless, and there will be sudden rise in temperature, and because of sudden rise in temperature and precipitation earlier, there will be rise in humidity of the air. Okay, but the air pressure here will decrease considerably or remarkably, and in this weather there will be no precipitation, but we may observe a little occasional drizzles and all. So this is what happens during the warm sector. Now we will move over to cold fronts. So during cold fronts, the temperature registered, it remarkably decreases. So the registered temperature, it remarkably decreases with the arrival of cold front. Okay, and there is change in wind direction from southerly to southwesterly and westerly. So if the wind is moving in southern direction, then it will move to southwest or west direction. Okay, and the sky is again covered with clouds, with, so the sky will be covered with clouds, and here precipitation will start soon. Okay, and this precipitation will be seen in cold frontal precipitation. So in cold frontal precipitation, what will become? The sky will become overcasted by cumulonimbus cloud. So in warm frontal precipitation, we had nimbostratus cloud, while in cold frontal precipitation, we will have cumulonimbus clouds, which will yield heavy shower. Okay, and because the warm air here is, so here the in warm frontal precipitation, the warm air was rising by itself. But in cold frontal precipitation, warm air mass is forcibly uplifted. Okay, so because it is hurriedly uplifted, the cold frontal precipitation is formed. It forms heavy downpour. Okay, heavy downpour with thunderstorms and lightning. Okay, so here we will have thunder, lightning, but the precipitation will be for shorter duration as compared to warm frontal precipitation, and it will be less widespread. So the warm frontal precipitation was more widespread and was for long period of time because the air, warm air was rising by itself. Okay, but here the huge amount of air is raised by cold wind forcibly in short duration. So the area that is covered will be less, and the precipitation will be for shorter duration. Okay, lastly, sorry, I forgot to write. Lastly, we will have cold sector. So in cold sector also, like warm sector, the weather changes remarkably with the passage of cold front and arrival of cold sector. So as the cold front moves and the cold sector arrives, the weather it changes remarkably as the sky becomes cloudless. So the sky becomes clear. Okay, and there is considerable rise in air pressure but decrease in specific humidity. So in warm front there was considerable increase in humidity but there was decrease in air pressure. But here it is just opposite. The humidity will decrease while the air pressure will raise. Okay, and the wind direction it changes from 45 degree to 180 degree, and it thus becomes true westerly. Okay, and after the occlusion of the cyclone, the weather conditions of pre-cyclone period are again set. So after all this happens, after the cyclone is gone, the weather conditions which were prevailing earlier, they are only set again as it is. Now we will look into life cycle of cyclones. So the life cycle of cyclones, as we have done in frontogenesis, it is same like that. It is completed in 6 successive stages. So the first stage is convergence of two air masses. So there is convergence of two air masses with contrasting physical properties, and they are moving in opposite direction. So we have cold air mass and we have warm air mass. They are moving in opposite direction and hence they are forming front. Okay, so stationary front is formed here. In second stage, it is also called as incipient stage. Okay, so this stage is also known as incipient stage. So during this time, the warm and cold front masses penetrate into territories of each other and thus wave-like fronts are formed. So this is cold front and this is warm front. See, always the warm front is denoted by this saucer like structure, and the cold front is denoted by this conical structure or triangular structure. And now this is cold front and this is warm front. Okay, now as we can see that cold front or cold air is trying to occupy the territory of warm air, while the warm air is trying to occupy the territory of cold air. So here we can see wave-like structure is formed. Okay, so we call these front as wave-like fronts. Now in the third stage, it is a mature stage, and here the cyclone is fully developed. Isobar becomes almost circular. So here we can see isobar have become almost circular. Sorry, here we have circular isobars. Okay, and this is a mature stage. In the fourth stage, what will happen is the warm sector is narrowed down. As we can see, the warm air is having just this much area, while the whole area is covered with cold air. Okay, now the cold front come near to the warm front. So cold front, it is coming near to the warm front in this stage. Okay, and in fifth stage, occlusion of the cyclone will start. As the cold front, it is advancing towards the warm front, and it finally overtakes the warm front. So the occluded front is formed. Why? Because the cold front, it has occluded the territory of warm front, and here we can see a cold front is finally overtaking this area. And at last, in the fifth stage, it is also known as the cyclolysis stage. Okay, here the warm sector is completely disappeared, and the ultimately the cold air, it takes place of the warm air, so the territory is occupied by cold air, and ultimately cyclones dies out. Okay, so here the cyclone dies out, and this process is known as cyclolysis, while this process is known as cyclogenesis. Now now we will take an example of, or a case study of, temperate cyclones, how they affect India. So, as we have heard the name of Western disturbances, so what happens during the Western disturbances? Consider this as the area of Mediterranean Sea. This is Africa. Okay. This is India. So now, what will happen? Here we can see the low pressure is generated, and a temperate cyclone is formed in the Mediterranean Sea. Now what will happen is this temperate cyclones will be dragged by westerlies. Okay, so firstly we will see this is high pressure belt here, and this is high pressure belt here, and in between there is Mediterranean Sea, which will be having low pressure, and because it is having low pressure, the cyclones, the air will converge here. Okay, and cyclones will be formed. Now these cyclones, they are dragged towards their east, okay, by the westerlies. Now as they move, they gain moisture from Mediterranean Sea, Black Sea, and Caspian Sea. Okay, and this happens during winter time. Why? Because during winter, this area and this area will be having low temperature, and hence, because Mediterranean Sea is a water body, so it will be having considerably high temperature, or it will be having comparatively high temperature. Hence, there will be low pressure here, and the temperate cyclones will be generated. So now these temperate cyclones are dragged towards their east by the westerlies wind, and There is we have Himalayas here. This is Indian border. Consider this as the Indian border. So they reach India. Okay. As they reach India in the western side. So this is the western side of India, and they are not a part of normal monsoon. Hence they are disturbances. Okay, so they are not the part of normal monsoon, hence they are called disturbances. And because they reach India from its western side, this is the western border of India, hence they are called western disturbances. So this is how these temperate cyclones, when they reach India, they get the name of western disturbances. Okay, so these western disturbances, they move through Pakistan, Afghanistan, and then they reach Indian subcontinent. And Indian subcontinent, they cause some precipitation during winters. And the area which gets its precipitation is Punjab, Haryana, Western Uttar Pradesh, Rajasthan, Jammu Kashmir, and some part of Gangetic Plains. Okay, so these are the region that receives rainfall or small amount of precipitation because of western disturbances. So that was about tropical cyclone. Western disturbance is also a type of tropical cyclone which is generated in Mediterranean Sea, and it is dragged by the westerlies towards the Indian subcontinent. Okay, so this was about temperate cyclones. Now we will look over to tropical cyclones. So temperate cyclones are the cyclones that are developed in the region laying between Tropic of Cancer and Tropic of Capricorn. So between these two regions, that is 23.5 degree north to 23.5 degree south, all the cyclones that will occur will come under tropical cyclones. Now we will look into salient features of tropical cyclones. So tropical cyclones have diameter of about 80 kilometers to 300 kilometers because they are very wide. Okay, and the smallest cyclones, when they become very small, their diameter is restricted to only about 50 kilometers or even less. Next we will look into velocity. So velocity, it ranges from 32 kilometers per hour to 180 kilometers per hour, but it sometimes even it ranges up to 400 kilometers per hour. Okay, these tropical cyclones, they are strong over oceans. Why they are strong over oceans? Because here we can see a good amount of temperature gradient and pressure gradient. Okay, and they are weak over land because they can't get moisture from land. Okay, next we have extreme low pressure in the center. So these are characterized by extreme low pressure in the center, and unlike temperate cyclones, they will have no temperature variations, and they will not be always mobile. So they are not always mobile. Next, they become disastrous in nature. Sometimes they become their speed, it ranges from 180 kilometers to 400 kilometers. So they become very disastrous in nature, and they causes various type of natural hazards. Okay, Now we will look into various types of cyclones. So, on the basis of their strength, cyclones are basically categorized into four types, that is, tropical disturbances, tropical depressions, tropical storms, hurricanes, and typhoons. So, firstly, we will have tropical disturbances. Tropical disturbances, they are migratory waves like that of cyclones. They are like cyclones, okay, and they are associated with easterly trade winds. So they are associated with easterly trade winds, hence they are called easterly waves. And these winds, they move towards center with low speed. So they have low speed, hence they are weak. Okay? And though they move in westerly direction, they are under the influence of trade winds. Okay? So they move in the direction of westerlies, but they are under the influence of trade winds and with a low velocity. So trade winds having low velocity, so they are more extensive and widespread, and hence they influence, because they are more extensive and they are widespread, they influence the weather condition of both tropical region as well as subtropical region. Okay, so they are influencing the temperature or the weather condition of tropical and subtropical region. Their extension is between 5 degree to 20 degree north. Okay, in the western part of oceans. So in the western part we can find these type of tropical disturbances. Next we have tropical depression. Tropical depression are center of low pressure surrounded by more than one isobars of very small size. So they are, so these are having low pressure surrounded by closed isobar of comparatively high pressure. They are small in size, and because there is low pressure in center, so the wind will come in the center, and the velocity of wind, it ranges from 40 to 50 kilometers per hour. Okay, their direction and their velocity is highly variable. They sometimes remain stationary, or sometimes they move from one place to another. So they may remain stationary for several days at one place, while sometime they will move. They are okay. They are formed in the vicinity of ITC, okay, Intertropical Convergence Zone, but they develop on trade wind belt. So their area is ITCZ and trade wind belt. Now next we will have tropical storms. Tropical storms are low pressure centers, and they are surrounded by closed isobar wherein the wind moves through the center towards the center with the velocity ranging from, so here the velocity was 40 to 50 kilometers per hour, while here the velocity will be 40 to 120 kmph. Okay, these types of cyclone, they frequently develop over Bay of Bengal and Arabian Sea during summer seasons. We can see them. Okay, next we have hurricanes and typhoons. So hurricanes and typhoons, they are extensive tropical cyclones surrounded by several closed isobar. Okay, so they are surrounded by many closed isobars. Okay, and they are given many names. uh, in different region they are given different name. So hurricanes are, they are called hurricanes in USA, typhoons in China, willy willy in Australia, cyclones in Indian Ocean, then typhoon in Japan, etc., etc. So these hurricanes or typhoons, whatever we call them, they are most violent, okay, they are most disastrous, they are most hazardous of all atmospheric disturbances, okay, and their average speed is always more than 120 kilometer per hour, okay. These hurricanes, they are extensive, they are violent, but their climatic importance is limited, okay, so they are not very climatically important. Why? Because they are only related to destructions. Now we may say that temperate cyclones and hurricanes, they look similar, but hurricanes have difference from temperate cyclones. How? First is hurricanes are represented by more symmetrical and circular isobars. So they will always have symmetrical and circular isobars. Second is rainfall occurs from hurricane is formed. So the rainfall that occur from hurricanes is in the form of heavy downpour, okay, and is widespread and uniformly distributed, whereas precipitation from the temperate cyclone is confined only in warm or cold front. So the precipitation in temperate cyclone will occur only during formation of cold or warm front, while in in hurricanes the precipitation, there will be heavy downpour and it will be uniformly distributed, okay, and in hurricanes there will be no temperature variation. Unlike temperate cyclone, there will be no change in wind direction, and they are not associated with anticyclones, and they move from east to west direction. Sorry, they move from east direction to west direction, okay. So that was about type of tropical cyclones. Now we will look into mechanism of tropical cyclone. So to understand the mechanism of tropical cyclone, we will take the example of the tropical cyclone that occurs in Bay of Bengal. So tropical cyclones, they always occur in inland sea during summer. Okay. So why it happens during summer? So in summer, the sun rays are vertical in the northern hemisphere. So the insolation will become more in the northern hemisphere, and the inland sea that is surrounded by landmass, continental landmass from most of the part is surrounded by continental landmass. So it will act as a heat sink zone. Okay. So here what will happen is there will be transfer of heat which will be starting from continent or the land mass, and it will move towards the water body, okay, hence heating the water body by the process of conduction. So this will be conductional heating, okay. Now in the course of time what will happen, the sea surface temperature of the inland sea will raise, okay. So that because of conductional heating, the temperature of inland sea will increase, and it will reach up to 27 degrees Celsius or more. Now, as the temperature will reach such an will, will be such so as the temperature will reach such an extent or such a range, now what will happen? The process of convection will start from the surface. So now convection will start, and The inland sea, there the temperature is also regulated by warm oceanic current. So the warm oceanic currents will also regulate its temperature, hence the temperature will also rise because of warm oceanic currents. Now, the regular convectional phenomena creates centralized low pressure which further intensifies. Now, as the convection will start, so the low pressure there was already low pressure because now this inland sea will have high temperature. But what will happen now? Because the process of convection has started, the low pressure will intensify, and this low pressure will intensify furthermore because of first is ITCZ as it will shift northward, so there will be a belt of ITCZ on this inland sea of Bay of Bengal. Okay, and now the convectional second reason is the convectional current, they are rising. Okay, and when they rise they reach their saturation level, and as they reach their saturation level or condensation, they will release their latent heat. So as they will release their latent heat, this will heat up the air, and the air will get energy and it will rise furthermore, hence intensifying the low pressure on the surface. Okay, so low pressure is intensified even more by the release of latent heat. Third reason is there will be strong high pressure condition in the upper troposphere which will regulate the low pressure system in the oceanic surface. Okay, so as there will be high pressure condition in the upper troposphere, which will regulate low pressure condition. But always remember, this high pressure condition will never or will not occur during cloudiness or vertical absorption. Sorry, during vertical aberration or during cloudiness, this type of condition, this high pressure condition will not occur, and hence clearly the cyclone will not occur if the high pressure condition will not prevail. Okay, now this area will become a low pressure vacuum, and now as this depression, this will be very intensified low pressure area. Now this low pressure vacuum will be covered or will be filled by the winds from different direction. Okay, and the wind that are coming, they will acquire a circulatory motion. Why? Because of Coriolis force. And now these winds, they will acquire circular motion. Okay, and these winds, this circular motion, it comes under the influence of easterlies, and it is drifted towards its west. Now it is drifted westward near the continental margin. Now as they come near the continental margin, they create high turbulence in the atmospheric phenomenon characterized by windstorm, heavy precipitation. Okay, so here we will have windstorms, heavy precipitation and all. But as they enter the hinterland, the process of convection becomes slow. Why? Because they will not have moisture on the land. So on the land there will be no moisture. So the process of convection will become slow, and hence the latent heat of condensation will not be supplied. Okay, and the pressure gradient will drop. So everything, as they reach towards the hinterland, there will be low convection, and there will be latent heat of condensation will not be supplied, and there will be there will be pressure drop, and hence as they reach the hinterland, the cyclone will die off. Okay, and this process is known as cyclolysis or death of cyclone. Okay, now this cyclonic motion over the Bay of Bengal is generally developed during the month of September to October. Now, why it develops during the month of September to October? See, in September to October, these months are like clear, calm atmospheric conditions are there. There is less cloudiness, clear sky, more insolation, like more heating from the sun. There is presence of ITCZ over Bay of Bengal. Okay. Next reason is the low pressure cell of South China Sea is agglomerated with the low pressure system of Bay of Bengal during this time. Okay. And there will be sudden increase in pressure gradient between the subtropics and Bay of Bengal. Now, because this is the month of September to October, so there will be a sudden increase in pressure gradient. Okay. So this was the mechanism of tropical cyclones. Now we will look into stages of cyclone. So we have stages of cyclone. As the observer, see if the observer is standing here, the cyclone will pass from the area. So if this is the area, the cyclone will pass. So there will be various climatic conditions that the observer will observe. So during the initial time, there will be very strong circular winds. So here, when this part of the cyclone will come, there will be very strong circular wind. Then small convection will start, slow convection will start. Then as it reaches to the mid of the cyclone, there will be calm condition, calm atmosphere. After that, slow storm will occur. Okay, as we have reached this side of cyclone, so the slow storm will occur, and then we will find wind, but these winds are not as strong as they were initially. Okay, and lastly we will have cyclolysis process. Okay, now we will look into vertical and horizontal component of cyclones. So vertical component of cyclone, this is the vertical component of cyclone. So here we will have, this is the zone of inflow. So this zone of inflow, it ranges from 3 to 7 kilometer from the surface. So here the wind will come inside. Okay, as this is a low pressure belt, this is a low pressure area, eye of cyclone. This is eye of cyclone, it is low pressure area, and the outward area is high pressure area. So wind will blow from high pressure area to low pressure area. So this will be known as zone of inflow, and these winds are cyclonic winds that will come inside this area, that is this area. So here the air is rising. So this area will be known as zone of upwelling or zone of ring. Okay. Next we will have this area where the wind are seen as going outwards. So this is known as wind of zone of outflow. Okay. Lastly we will have eye of cyclone. So this is the eye of cyclone. Here we can see calm condition. Okay, because this is low pressure area. Now this was the vertical component. Now we will look into horizontal component of cyclone. So horizontal component of cyclone, this is the low pressure area. This is known as eye of cyclone. Okay, this is calm zone and it ranges from 10 to 12 kilometers. This area here, this belt, is eye wall. It ranges from 80 to 100 kilometers and it is most destructive one. Now there is wind shear. It is the inflow of wind is from here. Okay. So it is the area between high pressure outer ring. This is high pressure outer ring, the outermost ring, and the low pressure zone. So area between this is known as wind shear. Okay. So these were the stages of cyclone and components of cyclone. Now we will look into basic differences of temperate and tropical cyclone. So here we have tropical cyclone, while here we will have temperate cyclones. So tropical cyclones, for their origin, we need various geomorphological, oceanographic and atmospheric factors like conductional heating, ITCZ, inland sea, latent heat of condensation, etc. etc. So it requires a lot of things, while for temperate cyclone it simply requires two converging contrasting air masses which are converging for the process of frontogenesis. Okay. Next we will have velocity of wind. So in tropical cyclones, as there is exchange of mass and energy between earth and atmosphere, more exchange of mass and energy between earth and atmosphere, and it is in tropical region, so convectional phenomenon will also be more. So here the velocity of wind is very high and it is more than 120 kilometers per hour, while in temperate cyclone, as it is in cold area, comparatively cold area, so there will be less exchange of energy between earth and atmosphere, and the range of velocity will range the wind velocity will range from 40 to 60 kilometers per hour. Okay. Rainfall will be more in tropical cyclones. It will be about 150 to 200 centimeters, while in temperate cyclones it will vary from about 50 to 80 centimeters. Okay. The period of existence is about 7 to 10 days. Okay. While this temperate cyclones, it has great impact as it is intercontinental in nature, so they survive up to 5 months, as we can see in the case of western disturbances. So they cover such a long area, so they have to survive for longer period. Next is propagation. So tropical cyclones are influenced by easterlies and they are drifted westward, while the temperate cyclones, they actually move towards their east within the same zone of propagation, followed by westerlies. So they move towards their west while they move towards their east. Now with this we complete cyclones. Now we will move over to anticyclones. Anticyclones are simply high pressure condition when it prevails at the center, or we have high pressure, centralized high pressure surrounded by low pressure belts. It is known as anticyclone. And during anticyclones there is no cloud formation. We will have cool nights and warm days. Okay. So if we explain anticyclone, they are simply high pressure system developing over the surface of earth by several thermodynamic factors. So anticyclones in their formation and impact are entirely different from cyclones. Why they are entirely different from cyclones? Because they have centralized high pressure that is surrounded by periphery low pressure isobars, and the pressure gradient force the air to move outward. So circular motion is the circular of wind is outward. So the wind is diverging, not converging. Okay. And this remains, just a second, in northern hemisphere it is clockwise, while in southern hemisphere it is anti-clockwise. Okay, so as we have anticyclones here, so these anticyclones will move in opposite direction as compared to the cyclones. So the cyclones, as they are moving in anti-clockwise direction in northern hemisphere, these anticyclones, they will move in clockwise direction in northern hemisphere, while they will move in anti-clockwise direction in southern hemisphere. Okay, now the circulation of wind, it is more of atmospheric condition. Okay, so the circulation of wind here, the impact will be more of atmospheric condition. There will not be any drastic meteorological impact like that was in cyclones. Okay, the weather conditions that will be impacted is like, first we will have less clouds and clear sky. So if we have high pressure condition prevailing over earth's surface, then the day are more warmer and the nights are more cooler, and because of this anticyclonic condition there is less cloudiness and there will be clear sky. Okay, now if this anticyclonic condition they develop during winter time in subtropical temperate latitude or region, then what will happen? The air mass is present near the surface of earth. If they are carrying some moisture, they may reach to the level of saturation and condense over the surface, forming minute droplets of water which are known as dew. And if the same process of condensation takes in the place or area with the average atmospheric temperature which is below freezing point, then a thin layer of ice will appear. So instead of thin water droplets, a thin layer of ice will appear, which will be known as frost. Okay, so we will have dew or frost formation during winter times because of anticyclones. Next, we will have fog formation. Now, how it will happen is, see, if the same process of condensation it takes place in the lower troposphere, but not above the surface of the earth. Okay, not just above the surface of earth. Then what will happen? The surface for condensation are provided by the hygroscopic nuclei. So here the ground will not be the surface, while the surface will be hygroscopic nuclei present in the atmosphere. And the dust particles, over these dust particles, small water vapors, they will condense. Okay, and they decrease horizontal visibility for up to 1 kilometers. This type of atmospheric condition is known as fog. Okay, lastly, if any in any region these high pressure are persistent or permanent, the prevailing climatology will be of arid, semi-arid or desert type. Okay, and if we look into prominent desert of tropical or subtropical zone, they lies in the latitude belt of subtropical high pressure zone. Okay, so in subtropical high pressure zone all these deserts lie. Why? Because the high pressure of subtropics it gets further intensified in the presence of cold oceanic current. So during cold oceanic current, what will happen? The temperature will lower down and the pressure will become more. Okay. So these conditions they prevail in desert. Okay, because of anticyclones. So that was about anticyclones. Now, if we look into basic areas of cyclones, that is temperate cyclones and tropical cyclone. So tropical cyclone, they are found here, here, Here the Bay of Bengal, then South China Sea, then west part of Australia. This is Gulf of Mexico. So in these part we can find tropical cyclones, while the temperate cyclones will be found in these areas. Okay, that is, and here they will be found here in southern hemisphere. Excuse me. Okay, so these are the area of temperate cyclones, while these are the areas of tropical cyclones. Okay, so with this we complete our topic on anticyclones and cyclones. So that was all for today, guys. I hope you enjoyed today's lecture. Let's meet in our next class. Till then, take care and have a nice day.